Hi student, this is Mr. Chen. Okay, so today's lesson I want to talk about the Year 9 Unit 4 assessment, Part A. So the assessment on shaky ground. So if you have a look at Part A, what they ask you to do is they ask you to construct 3 buildings by using paper. So the three building has different height. So the tallest one is 20 centimeters, median 17.5, and the smaller one is 15. So the reason why I do this video is I have many students write email to me and says they're actually not sure how to construct this model, and also they're not sure they didn't get the result they wanted, or they not sure how to get how to obtain the result. And I'm going to go through with you how I do with this. So I actually made the model yesterday. So it actually looked like this. Okay, so I actually made the model yesterday. So you can see the 3 building, the tallest one is 20 centimeters, 17.5, 15 centimeters. And all I use is 3 paper clip, 3 rubber band to hold the 2 rulers together, and also paper. So I use the A4 paper, and this is slightly thicker than the normal printing A4 paper. So you don't need to use the cardboard like the cardboard box cardboard. That might be a bit too thick, so it might be a bit difficult for you to get the resonation. Okay, so let's have a look what you need to record from this experiment. So if you look at the table here, it asks you to record the number of vibration in 10 seconds for each building. Okay, and you need to conduct the experiment. Each of the building you need to record 3, like trial 1, trial 2, and trial 3, and get the average of that. Okay, so it's also important to look at the method, step 3 and step 4 in the method. So step 3 says when the strip begins to resonate, vibrate strongly and regularly, count the numbers of complete vibration in 10 seconds, and step 4 says record the result in the trial 1 column for that strip. And then you have to repeat this step until you get 3 trials for each of them. Okay. So we probably have to clarify a little bit what is meant by resonate. So when we count 1 resonate by this. So if you look at the tall building here, that's 1 resonation. Okay, that's 1 resonate. 2, 3, 4. Okay, so what they ask you to do is to start with one of the buildings. So I'm going to start to move this ruler. Okay, so as a simulation of earthquake. Okay, gently to start with, until I get the resonation for any of this building. So when I say resonation, I'm talking about the big movement like this. I'm not talking about the small movement. Okay, we're looking for the big movement. Once one of the buildings start to resonate, we're going to count 10. We're going to count how many times they resonate in 10 seconds. Okay, so let's have a look. Okay, so I'm going to start to move this ruler gently forward and backward. Okay, you can see by moving very soft and gently, the big one is already start to resonate. So let's see it until big building. So when you have a full resonate, like forward and backward, you count 10 seconds. Okay, so now I get the full resonation of the big building. So you count 10 seconds, like 1, 2, 3, 4, 5, and then you count how many times it resonate. So my suggestion is if you can record the video, you record the video and then you count 10 seconds, and then so play back the video, count 10 seconds, and then count how many times you have. So okay, so you record the data for the big one, and then what you're going to do is the medium one. So I'm going to continue move the ruler forward and backward. Okay, and then so start from gently. Okay, gently the big one is moving, the medium one hasn't moved, and then until you increase the force you apply to the ruler by moving forward backward, you start to get the resonation on the medium one. Okay, and you can see that at this stage the big one is not really moving. So when you get the resonation of the medium one, again you record 10 seconds on this one. And then again, you do the smaller one. So increase the magnitude of it until you get the resonation of the smaller one. Okay, so just wait. Okay, so you can see down there, have a resonation of the smaller one. So you come, yeah, and then record 10 seconds for each of them. So you might be arguing with, okay, you have, Mr. Ching, you have 2 independent variables. One of them is the size of the building. The other one is the magnitude of the earthquake. So it is not a fair test. However, you need to understand for this experiment, what they ask you to get is, they want to see how the frequency is affecting the earthquake. So it's interesting because a lot of people will think when you have a big earthquake, the big one will vibrate will resonate a lot as well because it's a tall one. But when the resonation, when the earthquake increase, when I have very strong earthquake, the big one and the medium one hasn't really moved. It's a smaller one that is moving. So that's the purpose they want to get. So once you have all the results collected, you will have to put into the table here. Okay, an average, so you add all the 3 trials divided by 3, and then the frequency work out per second. So you might want to divide it by 10 to get 1 second from your average. Okay, if you have any other questions, please contact me or contact your science teacher. Okay, if you have no other questions, see you next time.